Hello everyone, these are notes on evaluating functions and multiple representations. So starting us off, we have a few ways to represent functions right now. The first way is to represent that function with a table of values. The other way, we also have worked with ordered pairs, which are these lists. So ordered pairs are just the coordinates of the points listed. This one is a function. Remember we talked about that last Friday. None of those x values repeat, so it is a function. This here is not going to be a function, but it does show one way that we can tell if it is or isn't. This is a mapping diagram. In this one, that x value has two arrows coming from it, which means it's being shared more than once. So this one actually is not a function. The other way we have so far is by showing a graph of the points that we have. And this graph is a function. It would pass that vertical line test that we talked about last week. The last way that we're going to represent functions is as equations. So functions can also be written as equations. One way we'll look at that, and what we'll see today, is with a y variable and an x variable. So let's say our y variable is equal to 2x plus 1. That is another way to represent a function. And what we're going to look at today is being able to go from an equation of that sort to being able to graph that function. So to be able to graph a function that is written as an equation, what you have to do first is make a table of values. So using this here, and then once we have that table of values, then we'll be able to plot those points on a coordinate plane. So looking at our first example, what our equation tells us is how these x terms are related to the y terms. So it says to be able to get y, we have to take whatever x is and add 4. So to be able to come up with what this is, we're going to take this number and add 4 to it. So for this first row, to be able to get y, this says we need to take -5 and add 4 to it, because -5 plus 4, that will get us equal to the y term. So -5 plus 4 gives us -1. So that means on our coordinate plane, if we label our x-axis and our y-axis, we're going to have a point at -5, -1. So left 5 and down 1. Okay. Keeping with the same pattern or the same rule, to get from here to here, we're always going to take that and add 4. So I'm going to add 4 here, and -4 plus 4 is 0. So that means I'm going to have a coordinate of -4, 0. So left 4, 4, and 0. We're not going up or down any. Continuing that same thing, now we have -2 plus 4. And -2 plus 4 gives us a +2. So now we have a point -2, 2. So left 2, up 2. Our last one, plugging 0 in for x. So 0 plus 4 is 4. So we have a coordinate pair of 0 and then up 4. Okay. We are not done yet though, because we have a function or an equation to represent this function. What that means is that we don't just have these 4 distinct points. They helped us graph it. We actually have a line that we are representing. So you're going to take those 4 points that we plotted and we're going to connect them with a line to show that we not only have just those 4, but we have everything in between those. Okay? So what we're doing is we're taking the x values and we're plugging in that x value, and we are following our order of operations. to be able to solve each of these equations for what y or our y coordinate is going to be equal to. So you always want to follow your order of operations and any other rules we have for solving equations. So for example, in number 2, if we plug in -4 for x first, we'll get something that looks like this. So 3/4 times -4, notice how we put that in parentheses, -2. Order of operations says we need to do the multiplying first, so 3/4 times -4, which is going to end up being, because those will cancel out, it'll end up -3, and then we subtract 2, which is going to be a -5. So on our coordinate grid, x and y, we would go left 4 and down 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. Same thing, now this time instead of a 4 in that place, we're going to plug in a 0. And I'm going to do some scratch work off to the left. If you have a whiteboard or a notebook paper, you can do it on there. Otherwise, your calculator, you can do this on your calculator as well. So in this case, so we have 3/4 times 0. And then we're going to subtract 2. So 3/4 times 0, that's just 0. And then subtracting 2 from that, 0 minus 2 is -2. So we have a point at 0, -2. Okay, next one, for the number 4, or an x value of 4, we have 3/4 times 4. And then subtract 2, and 3 minus 2 is going to give us 1. So we have a point at 4, +1. So over 1, 2, 3, 4, up 1. And go ahead and plug that value in for 8, or in for x. 8 goes in for x, so 3/4 times 8. And if you need to, you can change that 3/4 to a 0.75 and plug that into your calculator. Times 8 minus 2. This will go in there. So this would be a 6 minus 2. And 6 minus 2 is 4. So 8/4 is our last point, and that actually goes off our coordinate plane. So we're just going to approximate 2, 3, 4, 5, 6, 7, 8. And then up 4, 1, 2, 3, 4, so somewhere over there, right? And now what we're going to do is, again, just like we did for the top one, you're going to draw a line through those to show that this is not just those 4 values, but this line or this equation represents a whole bunch of stuff, because we could have plugged a 1 in for x, and that would have given us another point. We could have plugged in a 2. We could have plugged in a 7. Anything above or below what we have, we could have also plugged in there. So we're going to draw a line, straight line, all the way through those, and putting arrows at either end shows it keeps going on and on forever. Okay. If we don't have a table and a graph, sometimes it'll give you your function as an equation, and all we want to do is find the range, which that's exactly what we did here, but what we did, instead of putting it in a list, we had it written in a column on our table. So it's the same exact process, we just had this list of numbers here, so our domain numbers, and we're going to plug those in and find our range. So we have 3 values in our domain, so we're going to have to plug all 3 of those in to our function. So domain, remember, is x values, so all of these numbers are going to get plugged in for x in our expression. So we're going to have y equals 4 minus -2. And make sure you don't forget that negative sign and that it was already a minus, which means 4 minus -2, keep, change, is equal to 4 plus 2, which is just 6. And I'm going to write range range over here. And we'll make a list similar to that one. So my first one's going to be a 6. Keep going. We have y is equal to 4 minus x. So instead of x, we have a 3 this time. And 4 minus 3 is 1. So 1 is the next value in my list. And then our last one, still following that same equation or same function, 4 minus x. And this time we have a 5. And 4 minus 5 is negative 1. Okay, and I'm actually going to rewrite my list one more time. We're going to write it from least to greatest. So I have negative 1, 1, and 6 in my range. Okay. So each time we're plugging in values, evaluating those order of operations, and coming up with our range of values. And our range here was just in that list form instead. Go ahead and pause the video at this point and try number 4 on your own. So looking at this one, we have y is equal to negative 2/3. And we're going to plug in first a negative 12 and add 9. And you want to evaluate that and see what that comes out to. Then your second one, y equals negative 2/3. Instead of negative 12, we're going to plug in negative 6. And then our third one, our third domain value, we're going to plug in that 3, negative 2/3 times 3, and add 9. And see what that comes out to. And those will give us our y values, because we're finding what does y equal, which represents our range for those numbers. So evaluating these ones, 3 goes into 3 once, 3 goes into 12 4 times, so negative 2 times negative 4 is a positive 8, plus that 9 that we had would be 17. 3 goes into 3 once, 3 goes into 6 twice, so I have negative 2 times negative 2, which is a positive 4, plus the 9 at the end is a 13. And 3 goes into 3 once, 3 goes into 3 once, so negative 2 times 1 is negative 2, plus 9 gives us a positive 7. So our range, creating this list, least to greatest, is going to be 7, 13, and 17. Okay. So kind of summarizing what we just did there, we were given a function as an equation. From that equation, we took the x values that we were given and we plugged them in and evaluated with order of operations to find the y value, or what was equal to y. Same thing here, and then we plotted those points on a coordinate grid and drew those lines going through those points. On the right side, we did the same thing. We had an equation or formula for our function, and we plugged in our domain values and evaluated those to be able to find our new range for that set. So on that second page of your notes, kind of summarizing, again, we have 5 different ways to represent relations. We have our ordered pairs, our table, our mapping, equations, and our graphs. So filling these pieces in, just as review, ordered pairs. The domain is all of the x values or x coordinates, so the first numbers in that list. So we have a negative 1, a 0, and a 2 in our domain. In our range, the second number in each of those, and listing least to greatest, we have 2, 5, and 7. To determine if this is a function or not, we only look at the domain and we look to see if there's any repeats, and because negative 1, 0, and 2, they're all on their own, neither of those repeats, then yes, this is going to be a function. In this graph here, we have a circle that is drawn, and our domain is, remember, our x values, and our range is our y values. So looking at the x values, going left to right through this graph, the first part that the graph starts at is right there on the left, which is all the way over at 1, 2, 3, 4, negative 4. So I'm going to put the smaller number on the left. And it goes all the way to a positive 1 on our graph. At this positive 1 portion, our circle, or what's graphed, is everything to the left or less than or equal to that because it is a solid line. So our trick that I taught you guys last Thursday, we can put smaller number, larger number, fill in the sign for one, and it's the same exact sign for the other one, and it's an equal to also because it is a solid line. Right? Same thing with the y value. So we're going to put the larger number on the right. So it goes all the way, the highest point it goes to is up here, which is all the way up at a positive 1, 2, 3. And the smallest number that it goes to is here, which is a negative 2. So this is everything less than, if we think stuff down or below, less than or equal to 3. And then it's the same sign, and it's also going to be equal to because it's also a solid line. However, this one is not a function because if we ran our vertical line test, it would end up touching or going through a point at the top and a point at the bottom of that graph all at the same time. So it is not a function. Okay. Go ahead and finish these last few on your own. The equation one for the domain and range, that becomes a little bit trickier. So I'm going to have you wait on this one and we'll fill that one out together. But go ahead and try to fill in your domain and range for the table and tell me if you think it's a function or not. And then go ahead and fill in the mapping diagram for the domain and range and if you think that should be a function. And then at the very bottom of your notes, I want you to go ahead and summarize what you have learned today from the first part of your notebook page with our new portion about equations, and maybe if you learned anything about what we talked about in the past but maybe now makes more sense, add that to your summary as well.